This is question 23 from the GATE 2021 EE paper, where we are given a BJT circuit that is with a PNP transistor of beta 100. We are asked to assume that the base emitter voltage is minus 0.7 and are asked to find out for what value of R2 will the voltage across the collector resistor be 5 volt. Underneath the question, you will find the title of the NPTEL course or video relevant to this topic. A little bit of background about the PNP transistor. This is the PNP transistor with emitter, base and collector as so. The emitter current has a positive direction like that, and the base and collector currents have positive direction as so. The emitter is the terminal with the arrow, and in a PNP transistor the arrow points inwards. The active region, which is the region in which you have the current amplification, that is, collector current is the beta amplified version of the base current, is when the base emitter voltage is at diode cut-in and the collector emitter voltage is in this range. As usual, because of KCL, we have IC plus IB equal to IE. So let's go ahead and solve the problem. We are given that in this problem, beta, which is defined as IC by IB, is 100, right? And we are asked to find out for what value of IC is the voltage across the collector resistor equal to 5 volt. And we are asked to find out for what value of R2 is the voltage across the collector resistor 5 volt. We can see that if voltage across collector resistor is 5 volt, the collector current is 5 by 3.3K. And IB is equal to IC by 100. These both combine to give IE as IC plus IB, which is IC into 1 plus 1 over beta, which is IC into 101 by 100. Now VB, since we know what IC is, we know what IB is, and we know what IE is. And what is VB? Well, VB is 12 volt, so we get 12 volt here, minus the drop across RE, minus the drop across the emitter base junction. That is, VB is 12 minus IE into 1.2K minus 0.7. Since we know what IE is, we can calculate VB from here. Now, we can do a KCL at the base junction. These are the currents VB by R2, IB, and 12 minus VB by R1. Right? Actually, writing down the equations, the input current and the output, the current into the node is IB plus 12 minus VB by 4.7K, and the current leaving the node is VB by R2. Now the only variable here that we don't know is R2, because we get VB from here and we get IB from here. If you rearrange this equation and solve for R2, you will get R2 as approximately 17.05 kilo ohms. That is R2 is approximately 17 kilo ohms.